Meta just built a finger that can feel, not detect, not measure, feel. It's called Digit 360, developed by Meta AI, and this might be the most important hardware breakthrough in embodied AI this decade, because robots don't fail from lack of intelligence, they fail from lack of sensation. And that's expensive. Very expensive. Quick question: why can a $30 billion factory robot weld steel, but can't reliably pick up a raspberry? Hold that thought. Industrial automation is a multi-hundred-billion-dollar global market, but manipulation is still fragile. Robots drop objects, crush delicate materials, fail under surface variability. Why? They can see, but they can't feel. Digit 360 changes that. Built with GelSight, Digit 360 is not a basic force sensor. It has 18 sensing channels. It captures normal force, shear force, slip, vibration, micro-texture, deformation mapping. It doesn't output a number, it outputs a pressure field. That's a massive upgrade in data density. More data, better control models. Better control models, higher automation ROI. Let me simplify this. This is the difference between a thermometer and a thermal imaging camera. That's the leap. Here's the hardware stack: soft elastomeric skin, embedded deformation markers, internal micro camera, multi-angle LED illumination. When contact happens, skin deforms, camera captures distortion, AI converts optical flow into force vectors. This runs on embedded edge processing, low latency, sub 10 milliseconds. Why does that matter? Because slip correction must happen faster than gravity. That's control systems engineering, not hype. Imagine holding a glass of water. You don't consciously adjust your grip, your nervous system does. Digit 360 gives robots that loop. This wasn't a lab-only demo. Testing included calibrated millinewton force validation, texture, discrimination, glass, fabric, abrasive materials, shear slip onset detection, fragile object trials, deformable material handling, long cycle durability stress tests, metrics measured, slip detection latency, force resolution accuracy, signal drift over time, grasp success improvement percentage. That's enterprise-grade validation. Because if this enters manufacturing, downtime reduction alone could justify adoption. Now here's where it scales beyond factories. Digital commerce. Imagine a robotic system in Paris scanning a luxury jacket. It runs Digit 360 across high-end fabric, captures thread density, surface softness, micro-texture response. That tactile dataset gets streamed. You put on haptic gloves. You feel the garment before purchasing. E-commerce becomes sensory. This connects robotics, spatial computing, and premium retail infrastructure. That's cross-industry impact. But none of that compares to this. Prosthetics. Today, most advanced prosthetic limbs are mechanically impressive, but they're numb. With high-resolution tactile sensing integrated into neural interfaces, an amputee could feel texture, detect slip instinctively, modulate grip without visual confirmation. This merges robotics, biomedical engineering, and neural signal processing. High-value innovation stack, life-changing impact. Now let's talk workforce transformation. Because this affects jobs. Demand will rise for tactile ML engineers, multimodal sensor fusion specialists, embedded AI systems engineers, robotics control engineers, edge computing architects. Physical dataset engineering becomes a category. Meanwhile, script-based industrial robotics roles decline. Repetitive manipulation labor gradually automates. We shift from pre-programmed robotics to adaptive embodied AI systems. This changes capital allocation in automation-heavy industries. Let's zoom out. Language models gave AI reasoning. Vision models gave AI perception. Touch gives AI physical agency. This fits into the embodied AI strategy from Meta platforms. If humanoid robotics becomes viable, touch is mandatory. Without it, robots stay confined to structured environments. With it, they enter homes, hospitals, warehouses, retail. The physical world becomes programmable. Digit 360 is not a product. It's infrastructure. And infrastructure shifts industries quietly, until suddenly, everything depends on it. If you're watching robotics, AI hardware, or automation economics, this is the signal. Subscribe. Because the next decade of AI won't just think, it will touch,